So we're back, and this example, we're going to be looking at how we can solve base E equations. So, we're going to be using our property still, and we're going to be toggling back and forth between log and exponential form. Logs allow us to find the variable when it's in the exponent spot. Exponentials help us find the variable when it's in the argument of the log. So when we rearrange, voila, the variable gets exposed. So if we're looking at this particular equation, notice what? The variable, remember E is not a variable, it's a letter, not a variable. E is our irrational constant, 2.7 and change. So x is our variable, and if the variable is in the exponent spot, at some point when we've whittled it down, you're going to need to rearrange it and put it in log form to get the x out so you can solve for it. We will use our calculators on this. So again, you need to look at your calculator and get comfortable right here. Yes, just to the left of 4 is the ln, our natural log button, and up above it, its toggle switch in blue is e to the x. And so we're going to use that. Again, if we want to use the e to the x, we're going to use second ln, and if we just want to take the natural log, we're going to do the ln. Okay? So let's work our way solving this. At first, it kind of looks like a two-step equation. We see E, we're multiplying it by 3 and then subtracting 12. So before we rearrange this in log form, it needs to be e to the something equals stuff. So we need to eliminate everything else and whittle our way down to just see E. So think about that. What are we going to do? Well, to undo this, if we're solving to see, we haven't solved yet in the examples we've looked at so far today, but in this one we are. This one is an equation they want us to solve. So we're going to start with what you know. Let's undo the subtracting 12. So we'll add 12. And then we have what? 3 times e to the 4x power equals 15 plus 12 is 27. And now what do you think? Divide by 3. And we have e to the 4x equals 9. Right? So you see what we've done? We've isolated e by undoing these other pieces. And now all we have is e to the stuff equals 9. We are now at the point that we can rearrange. We're at a wall, e to the 4. How are we going to solve that? We don't know. So otherwise just sit and guess and check and multiple. That's not what we want to do. So when we're at a wall, like I can't do anything else, you can always rearrange. You can always rearrange. Doesn't always help, but you can always, rearrange. And that's what we're going to do here. So my students in the past would say we're going to logify it, which that's just when you take something in exponential form and put it in log form. So I would write rearrange. They would say logify. And why can you do that? Again, because they're inverse functions, and inverse functions, you can always rearrange them. So you could say log base E, but we really don't want to say log base E. What do we want to say? We want to say natural log. The natural log of 9 equals what? The exponent, 4x. And now one step to solving. You see how much that helped? It's like, oh my gosh, right? Now we can do that. To figure out what x is, of course, we'll divide both sides by 4. And be careful here. This is the natural log of 9, close parentheses, divided by 4. It is not the natural log of 9/4. Those are two different values. So be careful. Is it when you are doing this division, just make sure, is it inside or outside the parentheses? And so, of course, here we have the natural log of something, and then we're just dividing both sides by 4. At this point, it's a calculator problem. So you're going to say the ln of 9, close parentheses, divided by 4, and you get this lovely, can you see that? You get that lovely decimal. We want to round to 5 places past the decimal. Your book says 4. It still seems to skew it. So I like to do 5 places past the decimal, which is the nearest 100,000. So here we're just going to say divide. And then what do we have? Then we have x. And let's don't even say equals. Sorry. Let's do the approximate because we're rounding. So anytime you round, it is incorrect to say just straight up equals. So we can say approximately. So 0.5493, and that's 4 places. The next one is a 0, and then a 61443. So I'm going to round that up instead of just whacking it off there, truncating it. I'm going to round it to 1. Okay. All right. What does that mean? That means if you substituted in this number right here for x and said 3 times e to the 4 times 0.54931 minus 12, you would get 15. We're just solving, all right? Solving base e equations. Let's do another one, and then we will look at solving natural log equations. So this is going to be example 3b over here. And I'm going to write it out. I would encourage you to try to do this on your own and just press pause once I have it written out, and then you try to do it, okay? So 4e to the negative x plus 8 equals 17. So I'm going to say press pause. You try to solve this. Get as far as you can. If you get all the way to the end, hooray! If you get as far as you can, then watch it and see, ooh, did I do that right? Oh, yeah, that's right. Then press pause and then do it, okay? That's kind of how we would do, how we do in class. Now you try or whatever. So same thing. Look, where is the exponent? Where is the variable? It's in the exponent spot. So think, what did we do over here? Well, we isolated base e to the exponent, and then we put it in log form. Okay, so we undid the subtraction and we undid the division. Well, that's essentially what we're going to do over here. We will subtract 8 from both sides. Okay, oh, press pause. All right, so if you press pause and now you're back watching, hopefully you did the same steps with me. You subtracted 8, then you divided both sides by 4, and you got 9/4 or 2 1/4. And then what? Then probably for some of you that negative on the exponent bothered you. Okay, so if so, what do we need to do? Well, that's just a coefficient. So just like over here, we had 4x. This is just the same as like negative 1x. Over here, we divided both sides by 4. So what are we going to do here? Divide both sides by negative 1, and that just changes the sign. So we have the opposite of the ln of 2.25 equals x. And when you just straight up calculator use, and you put that in your calculator and you get negative 0.81093. And that, sweet friends, is correct.